So that implies that this notion that we go about our everyday lives with thinking of ourselves as separate from each other and the cup is separate from the coffee that goes in the cup, that these notions are somehow, what would you say, superficial or contradicted at a deeper level?
They're artificial, definitely, and Bohm really stresses this, and it's a very interesting notion because in our Western way of thinking, we're so attached to the idea that when we come up with a concept like an apple or an electron or whatever, that exists out there, and we forget, it's kind of like fish unaware of the water in which they swim, that the conceptual pigeonholes we use, words, to describe reality, are phenomena inside our head. They're not out there. And most of the time this is a philosophical quibble, but when you get down to quantum physics, and this is one of the reasons that Bohm came up with the holographic idea, it starts to have real effects. And one of those is it's been discovered that if you take two subatomic particles like electrons, that in certain instances, when you do something to one, it will always affect the other, no matter how far apart they are. It's kind of like stories that you've heard of identical twins where when one is hurt, the other feels the pain. And the problem is that we can find no process known to physics that explains how these could be sending a signal back and forth. In fact,
because it would have to be faster than the speed of light.
Instantaneous. It would have to be an instantaneous signal, and Einstein's theory of relativity said you can't have instantaneous signals because it would mean that you could violate the time barrier and conceivably call your grandfather and tell him not to marry your grandmother. And most physicists say, well, this would be just too troubling to incorporate into a rational picture of reality. Bohm explains it in a different way, which is a very interesting way, and he says, if you imagine that you've got an aquarium in which you have a fish swimming, you have a TV camera facing the front of the aquarium, one facing the side of the aquarium, and you have a monitor attached to each camera. Now you also imagine further that you come from a culture that's never seen aquariums, never seen fish, never seen monitors or cameras. All you are privy to is the two images on these screens. He says that maybe, you know, if you look at these two screens, you're going to see a side view of a fish and a frontal view of a fish. And because you don't know what the deeper reality is, the reality of the aquarium, you may assume that these are two separate things. But
two different fish.
Two different fish, two different objects. But every time one fish moves, the other is going to make a corresponding movement. And you may then jump to the conclusion that somehow the one fish is signaling the other or communicating the other to say, hey, do this, instantaneously. And Bohm says this is what we've done with subatomic particles, that we assume that an instantaneous communication is going on when that's not really what's going on at all. At a deeper level, a very holographic level of reality, every particle in the universe collapses to a sort of cosmic unity. They're not signaling each other. They're like that fish where there's the level of the aquarium. And so what that means, talking about words, is that there is no separation between electrons. Furthermore, there's no separation between people. And this has all kinds of very boggling implications, one of which is that we've always tried to understand, for example, psychic phenomena, like how could I get information out of your head in my head, as some sort of signal going back and forth. But if we're organized, if we live in a universe that's organized holographically, you no longer have to tackle it that way. It could be that I have the entire universe and every neuron, every cell, every atom, every electron in my head, and you do also. So when we can access that, we can access information that seems to be beyond our normal sensory reach.
Well, you know, I'm very interested in psychic phenomenon, and I know you've had many personal experiences, and I want to touch on it, but this is not a model that was developed in order to explain psychic phenomenon. I think to neuropsychologists like Carl Pribram, the fact that it happens to provide an explanation for psychic phenomena is almost a bit of an embarrassment, that he developed the holographic model because he was trying to come to terms with memory.
Right.
So let's talk about that.
Sure. Pribram was working under a very famous neurophysiologist named Carl Lashley, and it was at a time when it was believed that memory was stored in a specific spot in the brain, and there was something called the proverbial grandmother cell, that there was literally a cell in your brain that contained the memory of your grandmother, of what you knew about your grandmother. And so they did a rather gruesome series of experiments for animal lovers, but it came out with some very profound information. They took rats and they taught them how to run mazes. And then they would surgically remove various portions of the brain, Pribram and his mentor, Carl Lashley. The reasoning being that if they could remove a portion of the brain and the rat could no longer run the maze, they'd found the area of the brain where the rat's memory of the maze running ability was encoded. Now, every time they removed a different portion of the brain, they discovered that they could never remove the memory of how to run the maze. They could impair the rat's ability so it might limp through the maze, but they couldn't remove it. And really, you know, surgeons had known this for a while, doctors had known this for a while, because when people have head injuries, they don't forget half of the alphabet or half of their family or half of a novel they read. They have global memory impairment where their entire memory may be hazy. But memories don't seem to be stored in our heads in the same way that books are stored on a shelf. And it wasn't until the 60s when Pribram encountered the holographic model that says that the whole is contained in every part that he said, aha, this may be what's going on in the brain. Specifically, because a hologram is made out of interference patterns, the hologram that you see, that we talked about earlier is made out of the interference pattern of laser light, but it can be made out of the interference patterns of any kind of energy, electromagnetic energy, electricity, X-rays even. And so Pribram said, since our synapses are constantly giving off electrical impulses, these are like proverbial pebbles dropping into the sort of electromagnetic pool of our brain. They're sending out ripples that are constantly crisscrossing. And he believes that's what the brain hologram, that's how we think and how we remember is through that hologram inside the head.
It would apply in another sense, too, because if you take a hologram image and cut it in half or in quarters or in tenths, each time you reduce it in size, the image becomes fuzzier and fuzzier, even though the whole image is there, just the way memory would seem to be. And
it becomes fuzzier when you have portions of the brain removed.
Yeah.
Correct.
And Pribram then also noticed that the same principle applied for visual information processing.
Well, yes, it's very interesting. He did not make the discovery, but he came upon the research done by other investigators. And that is another very interesting thing. As you know, Mother Nature uses all kinds of mathematical languages. When we go to understand physical phenomena, we generally find that there's some sort of mathematical underpinning to whatever the phenomena is. There are uncountable mathematical languages. It turns out that the mathematical language involved in the making of a hologram is a system of mathematics developed by a Frenchman named Fourier. They're called Fourier transforms. Well, it also turns out that our brain uses Fourier transforms to translate visual information. And this is a very unusual state of affairs. It's kind of like discovering Eskimos speaking Spanish. It's not proof that the brain is a hologram, but it's suggestive that the brain is a hologram. And it turns out, in fact, all of our senses appear to rely on sort of Fourier transforms, that they all seem to use the same mathematics. So again, here's evidence that the brain uses the same mathematics to decipher the sensory world as are involved in the making of a hologram, which is, as I say, not proof, but compelling evidence that something is going on there.
Well, what this seems to suggest is a new way of looking at consciousness itself.
Very much so, yeah. It's an interesting thing. I have to say that I differ a little with Pribram, because Pribram thinks that the brain, as I said, that it's the electrical interference patterns in the brain. It is a brain hologram. I'm kind of a mystic because, at a young age I had an out-of-body experience where I left my body, and it became quite apparent to me while I was having this experience that I was thinking, but my brain was back in my body, which I could see in my bed. I knew it wasn't just a dream because I floated out over the ground outside my family's house, and I saw a book lying on the ground, and it was a book by the French short story writer Guy de Maupassant. And the next day, a neighbor said, by the way, Michael, I lost a library book by Guy de Maupassant. Have you seen it? And I thought, well, I floated over it last night. I didn't tell the neighbor that. But there was the book. And I was always I'm still very scientifically oriented. I want to understand the world in scientific terms. But it was really the first time that I sort of had to confront, the difference between my spiritual beliefs that we can survive, our bodily death, and this deeply held belief, scientific belief of mine that it's the brain that's doing the thinking. And I realized I had a kind of epiphany where I thought it isn't the brain that's doing the thinking. So I am not entirely certain that it's just the electromagnetic interference patterns that is the brain hologram, because those obviously would perish when the brain perishes. I think there might be some subtler level, some subtler energy that we haven't discovered with our technology that's involved in this also.
Well, Bohm's model is relevant and interesting at this point because he's not dealing with the universe as a hologram made out of electromagnetic interference patterns. He's looking at quantum wave potentials, which are at a much deeper level. And I must say, I've heard Pribram discuss it much the same way. There are quantum wave potentials in the brain itself, which is a much more deeply embedded level of energy and matter than the electromagnetic level.
Right. Bohm, it's a funny thing in science. The great physicist Hermann Bondi called it the lure of completeness, that we tend, when we find some sort of outermost perimeter to what we can measure, we assume there's nothing beyond it. And I refer to it, it's kind of like you know, in ancient times when we only knew a certain portion of the world, people always seem to say beyond the edge of the map there be monsters, that there was nothing there. And the same thing is going on in physics, that we have, with our technology, reached down to a certain level in reality, and it's a common prejudice among many physicists that beyond that level, there's nothing exists. There be monsters. There's just a void. Yeah. And it's an interesting thing that we, as I say, we have to have this lure of completeness. We have to feel that our knowledge of the universe is all that exists in the universe. Bohm, I think, is very wisely is one of the few physicists who comes out and kind of says the emperor has no clothes. Says what rational basis to? It's just prejudice that we assume nothing exists beyond this level of reality. And he feels that there are all kinds of domains of reality beyond this level, this microscopic level, and he theorizes that there may be untold, uncountable, subtler energies in these levels. The quantum potential is one. It's a theorized field that has not been measured or discovered with science, but Bohm feels there's evidence to posit its existence.